Hello, let's solve this question today. Here this question is move zeros. So we are trying to move zeros. So we need to move, given an array of numbers, write a function to move all the zeros to the end of it while maintaining the relative order of the non-zero elements. So we have to move all the zeros from anywhere in the array to the end. So we are supposed to do it in place without making a copy of the array. It's very easy when we make a copy of the array. If we make a copy, we just copy these elements to the front and we are done. But if we are not supposed to make a copy, let's see how we can do it. So we have two cases. One is like this, where we have 0 1 0 3 1 12, and the other one is the same thing, but when it starts without 0. So, 1 starts and 0 is next. So these are the two cases, possible cases. So it starts with 0. There are other cases you can have ending with 0 and ending without 0. So let's see if those cases make things different. So so we have to minimize the total number of operations. We have to try to minimize the total number of operations. So there are hints and topics. So let's see this. It has 2 pointers. So there is one concept of 2 pointers that we can use, which it is said in the related topics, and here we have some hints as to how to proceed. So let's see how we can use the 2 pointer approach to solve this. So if we have so let's say I have two let me get 2 pointers I and j. So I and j starts at 0. So we'll move j. So I am considering the first array, so I'll move this below. So I'll move j to the position. So they both start at 0, and then I'll move j to the position of where there is a non-zero element. Then I keep I at the position where there is a 0 element. Then I will exchange those two, swap them 1 0, and then I will make this I plus plus and j plus plus. So these three will be the same. So I will increment I and both I and j. So here I will be here, but it's still at 0's place, so we don't have to move it. But for j I will keep incrementing it until I will increment it once here, but I will keep on incrementing it till it comes to non-zero element. Again we can exchange this with this. Then I'll quickly do that one also, so I can copy and paste it here, so it will be quicker. Oops. So I will get this 3 here, swap it with 0, move I one place by 1, then I move j by 1, j as long as it's not 0, so it comes to 12. So I can swap these two and I'm done. So that's the algorithm we are going to do. So I'll make so swap these two and we are done. So we go as long as one of them goes to the end. So j will be at the end, and then so we are done. J will be out of the array, so we are done. So what's the issue with this? So here we started at I is 0, so it's good. So here we start, if we start j at here, j here, I j, so if we start sorry, if we start I here, and if it is here, so if j is at the non-zero place and I is here, this is incorrect, because we want I to be, j to be here. So in this case we have to first move j to be after I, not before I, and at a position where there is a non-zero element. So we have to move j after I and at a place where there is a non-zero element. So if j is moved to this location, it's same as the previous occurrence, so it's same as this thing. That's good. So first we have to move j to a location that's greater than I and to a location where it's not equal to 0, and we move I as long as we are at a 0. So we'll first move I and then move j to a place greater than I and it's a non-zero, and then we keep on swapping and repeating till we come to the end. So it will be minimal number of operations, so we did only like 1, 2, 3 swaps and we were done. So let's try to code this up. So we have to start with 2 pointers, int I equals 0 and int j equals 0. So while I less than, so we have to code go as long as I is less than and j is less than nums dot length, and if so we have to go from as long as we have to first move I, so we'll go I as long as I is not equal to 0. Sorry, we'll add I, increment I as long as it is not equal to 0. I plus plus. So and then else, after that we'll add the else if j's case. So j should be incremented as long as it is less than I. It can't be here if it is less than I, or it is not equal to 0. If j is less than or equal to I, so it can't be less than or equal to I, or nums j equal to 0. It can't be equal to 0. For as long as these are the cases, we need to keep on incrementing j. And then else I can now we need to swap this. I can move this to a separate function. So once these are in the correct positions, when I is at the 0 and j is at a non-zero element and greater than I will swap them. Nums I nums j equals is I, and ups nums I equals nums j, nums j equals temp. So we have done the swapping. So as long as j is, so let's go through the code again. So it's less than, okay, nums not equal to 0, I plus plus, j can't be less than I, so we keep on incrementing j, and j can't be equal to 0, so we keep on incrementing, and then we have to increment I and j at this position also. So once we swap this one, Okay, let's run this and see. Oops. Okay, that's very crowd. So that should work. Let's try the other case also. So we'll have a 1 here. So we don't want to start with a 0. There can be multiple cases, so we need to try one with 0 at the end also. That should work. So let's try with the empty array. We can also have with 0 only. Oops. That should be fine. Then we can submit it and see. That's good. Thank you for watching. Please subscribe.